We are now in lesson 10-3. We're going to be working with equivalent ratios. We'll start off with the launch problem.
The table shows votes for a new school team name. One friend says 2 grades voted the same. A second friend says the total vote for team name was the same. Use ratios to show how both friends could be correct. Which team name should the school choose? Explain.
Here are the possible answers that you can come up with. The first friend is correct because, the second friend is correct because, and the school should choose which one. You can pause the video and read through these answers. In lesson 2, we talked about how we can find equivalent ratios within a multiplication chart. Now we're going to be talking about how we can use equivalent ratios on double number lines.
You can use double number lines to find equivalent ratios. 1 to 2, 2 to 4, and 5 to 10 are equivalent ratios.
It's going to be important that when using a double number line, our zeros match up. When our zeros match up, when we move throughout our number line, whenever we have lines or little tick marks that match up exactly, those are going to be where we have equivalent ratios. You'll see more of this as we move along throughout this lesson.
Use the number lines to find ratios equivalent to 9 to 12. Find 2 ratios with lesser terms and 2 ratios with greater terms.
In order to do this, I have my 2 number lines. However, I need to make it so that my number lines match up 9 and 12. So right now, if I find 9 on my first number line and find 12 on my second number line, they are not lined up with each other. So what I have to do is I have to make it so that my number lines have them lined up next to each other. So I have to set my range. I'm going to start at 0, and I'm going to go to 9 because that is the number that I'm trying to find equivalent to 12, or my ratio is to 12. So I'll set that, and as you can see, I now have a number line set from 0 to 9, and I'm going to do the same thing for this one. Set it starting at 0, because remember I mentioned that our number lines have to both start at 0, and I'm actually going to set this one to 12 because it's telling us that 9 to 12 is our ratio. So since 9 to 12 is our ratio, those 2 tick marks match up. So it says find 2 ratios with lesser terms, and so I want to find, I want to find where my tally marks match up with each other. So 0, 0 matches up. The 1s do not match up. 2s do not match up. So the first one that I can see is 3 and 4. They are right on top of each other. So 3 to 4 is going to be equivalent to 9 to 12. And the next time that any numbers match up are 6 and 8. So 6 and 8, 6 to 8 is the equivalent ratio with lesser terms to 9 and 12. I also need to find 2 ratios with greater terms, so number bigger than 9 and 12. So what I'm going to do is I'm going to zoom out on both of these numbers so I can still see my 9 and my 12 are lined up exactly. And I need to find where my numbers line up exactly again. So I'm going to zoom out even more. So my 9 and my 12 are right on top of each other, and the next time that I see numbers one on top of the other is when I have 12 and 16. Those 2 numbers are right on top of each other, so those 2 numbers are equivalent ratios. The next time I see numbers that are matching completely is at 15 and 20. 15 and 20. It's kind of hard to see with this number line because I had to make the number so small. My trick was I held a piece of paper up to the screen, and I saw that these 2 lines were exactly lined up.
Use number lines to find ratios equivalent to 8 to 10. Find 1 ratio with lesser terms and 1 ratio with greater terms.
So what I want to do is I want to try and draw in my number lines. This is going to be not very good drawing since I'm using my mouse pad on my computer. And what I did was just went ahead, paused the video, drew it, and now I'm starting my video back together. So to kind of show you where I've started is I've drawn two number lines. I've matched up my zeros and I've matched up my 8 and my 10 because I know that these are going to be a ratio together. Now I have to figure out what other numbers are going to match up with lesser terms and what other numbers are going to match up with greater terms that are going to be equivalent with my 8 to 10 ratio. I'm going to pause the video again and draw it and then be back very shortly. You won't even realize that I've paused the video. It'll just be a picture that shows up. Okay, so now I'm back. My picture's here. What I did was I drew my 8 and my 10 were matched up, and I know that half of 8 is 4, half of 10 is 5, and so I know that my 4 and my 5 are going to line up because if 0 to 8 and 0 to 10 on my two number lines meet up, they have the same halfway point. So I know that 4 and 5 are going to be, 4 to 5 is an equivalent ratio to 8 to 10. And then moving forward, I found out that 12 to 15 is equivalent ratio from 8 to 10. This concept is very tricky when you are trying to make your number lines. How I knew all of these were equivalent is because I know my multiples and I know my factors. And so I was able to reduce 8 to 10 ratio. And so I divided both of them by 2. So 8 divided by 2 is 4. 10 divided by 2 is 5. So I knew that my top numbers were counting by 4s and that my bottom numbers were counting by 5s. And I should be able to each time get two numbers that were right on top of each other. So that's what helped me in creating this problem.
You can find equivalent ratios by multiplying or dividing each term of the ratio by the same non-zero number. This model shows the ratio 2 to 6. 2 blue circles to 6 red squares. To find an equivalent ratio by multiplying, multiply each term of the ratio by the same non-zero number. You can multiply each term by 2. First, multiply 2 times 2. Then, multiply 6 times 2. The ratio 2 to 6 and the ratio 4 to 12 are equivalent ratios. To find an equivalent ratio by dividing, divide each term of the ratio by the same non-zero number. You can divide each term by 2. First, divide 2 by 2. Then, divide 6 by 2. The ratio 2 to 6 and the ratio 1 to 3 are equivalent ratios. So, the ratios 1 to 3, 2 to 6, and 4 to 12 are all equivalent ratios.
This gives you an explanation more of how I found out the numbers that needed to be a part of our double number line. So I understand that both of them can be a little bit tricky, but we will practice this. Please ask questions when you come to school. I will be willing to work with you so that we all understand this and are all on the same page.
A volunteer at an animal shelter recorded the ratio of the number of dogs adopted to the number of cats adopted each month. She finds all the ratios are equivalent. Complete the table.
So knowing that we can take our ratio of dogs to cats, 4 to 5, and multiply it up, we need to figure out what times 4 equals 8. We should all know that that is 2, and so 5 times 2 equals 10. What you can do is you can find a pattern. Notice that we're counting by 4s here. 4 plus 4 is 8. 8 plus 4 is 12. So then we could count by the same terms over here, count by fives, 5, 10, 15, or more mathematically, what you can do is realize that we need to take something times 4 to get to 12, and then multiply that same number to get to this missing one. So 4 times 3 equals 12, so 5 times 3 equals 15. So in the month of March, I can say that my equivalent ratio is 12 to 15, which is also equivalent to February, which was 8 to 10. And then back to January when we had 4 dogs to 5 cats. Moving on to our got it problem, we want to write the ratio equivalent to 3 to 4. The correct answer is D, 6 to 8. I know this because I did 3 times 2 is 6 and 4 times 2 is 8. Moving on to our part 3.
You make a playlist with 6 hip-hop songs and 9 pop songs for a party. All songs play for the same length of time. Now you want to make a longer playlist and a shorter playlist that each have an equivalent ratio of the number of hip-hop songs to the number of pop songs. Part A. How many songs of each type can you put on your longer playlist? Part B. How many songs of each type can you put on your shorter playlist?
So what we need is we need equivalent ratios for 6 to 9. In order to do this, we can either multiply up to answer question A or divide down to answer question B. So if we multiply this, there could be a lot of different solutions for it. I like just going simple, so we're going to multiply by 2. If I double this, I know that I can still have an equivalent ratio of hip-hop songs to pop songs if I do 6 times 2, which is 12, and then also do 9 times 2, which is 18. So 12 to 18 is going to be an equivalent ratio as 6 to 9 is. We can then answer question B. So this answer right here goes with A. I'll put an A by it. This is A. And then to answer B, what we would do is divide it down. So 6 and 9 are both divisible by 3. 6 divided by 3 is 2. And 9 divided by 3 is 3. So the ratio is 2 hip-hop songs for every 3 pop songs, which is equivalent to 6 to 9, and again, 12 to 18. So this one is the answer for B. And here is our last got it problem for this lesson.
Write 2 different ratios equivalent to 4 to 10.
And the correct answer is B, 2 to 5 and 12 to 30. That's all I got for lesson 10-3. If you have any questions on this, just be prepared to ask in class, and we will work on it together.